Okay, what's log base b of 1, everybody? What's log base b of 1? Ooh, let's make him dizzy during the notes. What's log base b of 1? 0. Why is that not moving? Yeah. 0. What's log base b of b? 1. What's log base b of 1 over b? Okay, so these are basic exponent rules. I think we should add one more. Log base b of the cube root of b squared, just to get one more thing down, like what a fractional exponent means. And then sometimes we put it all together with fractions and negatives. What's the answer to this one? 3, 2, 1, go. 2/3. Okay. Oh, I don't want to talk about the A-B'ers. Do you want me to?
Yeah.
We ran a just basic how to evaluate logarithms because we're trying to graph. Guess what the class average was first hour?
73.
49%. Okay? And it was just based off of those ideas. I don't know what to do. Okay? I don't know what to do. I just can't. Anyway, all right. So I put those in there. That's from my old notes, from my old book, right? 5 to the third times 5 to the fourth is 5 to the seventh. You know that rule? So that is when multiplying powers of the same base, add the exponents. Because what's a logarithm? A logarithm is a different form of and starts with an E, and there's an X in the word. Thank you, exponent. Okay, is this first hour? Who doesn't answer anything? And then when numbers are divided, you subtract the exponents. This created a whole bunch of rules. Created the zero exponent rule. This created the negative exponent rule. Right? I covered that before, right? So I threw up there x to the 5th over x to the 9th. What is x? Where are there more x's? On the bottom. So just being smart and thinking about it, I'd have more x's on the bottom. But if I take 5 minus 9, that's how I get x to the negative 4th. That means they're equal. And that's where the negative exponent rule is created. Same thing with the zero exponent rule. Pretend you had x to the 9th over x to the 9th. 9 minus 9, 0. So x to the 0 must be 1, because x to the 9th over x to the 9th is 1. We have a question.
When you subtract the exponents, is it always numerator minus denominator?
Yeah, but you could always do, where are there more x's? Bottom. So we could do denominator minus numerator and put the answer in the denominator. So that's allowed. Right? Because all it really is discerning, that's a word, is where are there more x's and how many more. So don't be a robot and caught in a rule. Think, right? And that's what we want to be thinking about there. But the problem is you don't see these questions, that you just see a thing with a negative exponent. And you need to know that it just means flip. So I'm just telling you where it comes from. Now you need to know it as a rule and use it. This is often screwed up too between the first rule. You don't add those exponents, you multiply them. I feel like I keep hearing the door opening. Freaking anyone?
Yeah,
okay. Okay, something's going. Someone's jiggling. Is there like a ghost on the outside jiggling the handle? Okay, so that leads to this. That's already written down for you there, right? It really is the same terminology. When numbers of the same base are being multiplied together, you add the exponents. And guess what? This represents an exponent. That does represent an exponent. Just like up here. Why is log base b of b 1? Because b to the first equals b. 1 is an exponent. So that means this all represents an exponent. Okay. So that's why we can kind of use the same terminology. Let me just go over here. I'm struggling. Okay, that's why we can use the same terminology. You add the exponents because these represent exponents. They really do. And we could really say that these are numbers of the same base multiplied together. Because really it is what's going on behind the scenes. Right? That's why we can use the same terminology. Okay, numbers of the same base being divided, you subtract the exponents. That represents an exponent, and that represents an exponent when you are evaluating. Okay? You guys hopefully can handle that and understand it. Really good stuff coming up here, though. The powers that be, Mrs. Gray and Cooper have a great correlation between the rules and how they actually work. And we'll do that with the numbers. And then this is numbers that are not really numbers of the same base. This is the power raised to a power rule. You multiply the exponents because guess what? That's an exponent. And guess what? That was an exponent. What are you doing with those exponents? You are multiplying them. Okay? So that's kind of a stretch. That one's a little bit more of a kind of a tougher one, but we could call that a power raised to a power. You multiply the exponents. So that's always how we teach this. We compare them to the exponent rules. And now we're going to do our evaluations. Oh, I have to stamp because I gave you that one little sheet yesterday. I told you to do the odds, right? It was up on the top and also in the calendar. And I just, because I felt like it was too long. I really like the back page. I didn't really care about the front page. I should have done something more like do all of that little back section, but a couple here and there. But this is what your evaluation should have been yesterday. What is log base 2 of 4? What's the answer to that? 2. I don't get it. 2 to what power equals 4? 2. What's log base 2 of 32? 5. What's 2 plus 5? 7. Watch this. Numbers of the same, these exponents are added, so this comes from numbers of the same base multiplied together. Whoa. And now what we should do is our little exponent thing. Remember, you know what? I should do this right now. You could write it above if you don't want to change this. Isn't 4 2 squared, right? It isn't 32 2 to the 5th, right? Or what I could have done is just taken 4 times 32. Maybe that's what I want to do. Oh, sorry. I just can't make up my mind. What's 4 times 32? Isn't that 128? Yes, right? Hey, and then what's log base 2 of 128 when 128 is 2 to the 7th? What's the answer to that? 7. See? So I did them both ways. I did it with the new rule, and the new rule obviously came up with the right answer because, I know what the right answer is from up above. All right? All right. And then look at this. This is great. I love it. Log base 2 of 32. What is log base 2 of 32? 5. 2 to the 5th equals 32. What is log base 2 of 4? 2. 5 minus 2 is 3. Okay, well, let's do the division rule. That was the door this time. Okay, we were worried. Were you jiggling the handle before?
I was.
Yeah, I knew it. We knew it. He was jiggle. All right. Eric Rolls. Oh, wait, who is this for? I don't see his. Oh, Tyler.
Yes.
Well, wait.
Yes,
hold
up or
forward.
down.
So this is not for me.
Yes.
Okay, got it.
Thank you.
Sorry, Tyler. I think they moved you now.
Sorry about scaring you.
No, yeah. See, we were right. Yeah. We were right. All right. During the video, someone was jiggling the handle. We were freaking out. What's 32 divided by 4? Oh, he's still. What do you want? I brought it to the office. What's wrong with that? Did you see that dirty look? All right. What did I do? It's in no, not the office. The tech office. Yeah, tech. See, did I get just? What is? It's an EB student. All right. Anyway, what's 32 divided by 4? 8. What's wait? Why? There's not enough spots here. Log base 2 of 8. What's log base 2 of 8 then? 3, because 2 to the 3rd. A lot of stuff going on here. See? What's log base 2 of 4? What's log base 2 of 4? 2. What's 2 times 3? But let's do this rule. Okay, so this is what the rule is. We can go back and forth on this. We can make that an exponent here. Oh, how do I want to do this? I guess I could just go ahead and go ahead and take 4 to the 3rd. What is 4 to the 3rd, by the way? I got to write this down there. What's 4 to the 3rd? 64. I think I needed one more blank. And then 2 to what power do you think equals 64? 6. So we're just showing that it's allowed with numbers. We're getting the same evaluation. So obviously these rules have value. They have They have, they work. I don't know what else to tell you. I always like these, and I think the notes can be fast here. Because I think this is pretty reasonable. This is flat out memorization again, and then guess what? Wax on, say it. Wax off. You need something, Emily? Emerson?
No.
Whoops. All right. Anyway, so what do you think? A, B, C, or D are these actual rules? This is a little rough. Is A what we actually just expressed to you? Yes or no? This is what happens. People make up rules. Absolutely not. Is B what we actually expressed to you? Yes or no? Not quite. Okay, now this is a different rule. You'll find out what that is. All right. This actually is false. This would be log base 3 of 27 minus log base 3 of 9. So that is absolutely not a rule that we just expressed. But these are common misconceptions. These are common made up rules once students learn about this stuff. Is E good? Did I skip something? There's two E's. That must be C. Okay, but anyway, is this E good? Yes or no? Is this literally the rule? That's literally the rule. Is D a rule? Yes or no? Does this work? Yes, that's literally the exponent rule. And then is the last one a rule? Yes or no? I think it's kind of weird how they wrote that. I don't like that. It should really just be on the 9. So no, because what ends up happening here is this is log base 3 of 9, which is 2. And then, well, then half of 2 is 1. And then if the square root of 9, so I guess it does work with those parentheses. Those crazy teachers over there, all right? I don't know. They always got to mess with you. Okay. Oh, what did I say? Wax on, say it. That's really all this is, man. This is just, can you do the rules? The only point of these questions is, can you do them the correct way? What do we do with a product? What happens? It becomes a what? Product becomes a what? Product becomes a what? Product becomes a what? Is this first hour? What class is this? A product between two things becomes two logarithms. What do I put in between the logarithms? I put a piece of gum in my mouth. That's what I do right now instead of answer the question. Drink time. Let's go. No one's answered. Let's get a drink. Get your drink out right now. Let's go. So I ask again, what does a product become? What happens in between these two logarithms? First hour plus. Okay, plus. All right, good. Drink time's over. All right, and then this is y to the 7th. Oh, we have one more thing. What am I supposed to do with this 7 if I'm expanding? This is what expanding is, all kidding aside. You want to use one way of the rule. You want to expand them out to multiple logarithms. What do we do with that 7? Put it out in front is correct. That's the weird thing to say, but it is what happens. And then this is expanding. Wax on, say it. Wax up. Next section is the reverse. We're going to take this and turn it into that. Wax on, wax up, wax on, wax up. Why? To memorize the rules. Because they are actually used later when we actually solve and stuff. Okay, you know what? I'm just writing it. I don't have the power or right. I know you just learned it. I get it. Okay, right. Oh, you want to get nuts? Let's get nuts. I think what you probably should do, because we haven't been answering, so there's a little bit of unclearness in the air right now, is you should separate the numerator from the denominator. Dare I ask again, what goes in between these two logarithms? Subtract. Thank you, up in the front. She didn't like all that awkwardness. Okay, but then, and you know what? When you get good with these, you could write the final answer right now. These are 100% multiple choice questions, right? Because we could do a couple things here. Well, it might be too fast. What do I put in front of these two logarithms then when I have one of them base 4 of 16 and then another one of that square root of x? By the way, what is the square root of x the same thing as? Let's go ahead and do two things at once. Kill two birds with one stone. You can't say that. I love birds. I have a pet bird. I'm going to get canceled now. What is the square root of x? The same thing as x to the 1/2. What do I put in front of these logarithms now that I split them up into two? Addition. Only one person's answering. You said it too. Okay. And then, you know what? We're going to do all of this at once. So I'll leave this one alone. I'm trying to make my G's better so I don't get the, what's LO6? But you know what? Whenever this happens, you actually have to do it. What's log base 4 of 16? What's log base 4 of 16? 2. And then plus, what do I do with this 1/2? What do I do with that 1/2? Put it out, say it, in front. This is what it means to expand. Or let's see what the directions are. Express as a sum or difference. Sometimes it's just expand. All right. They're being real specific with the directions there. Now, what do I do with that 5? And then you can't evaluate a variable, so you're done. So when all exponents are pulled out in front, all logarithms are written separately, with the sum or addition, that means expanded. But then any number is evaluated if it can be. If this said log base 4 of 17, leave it alone. 4 can't be raised to a power to be 17, but in your head, okay, without a calculator. There is an answer for it. It's 2 point something, but only evaluate ones that are no calculator evaluations. Right? Let me guess, they didn't give you a pass. Dean's office, love it. All right, 31. Is that what that says? What is that? What is that right there? What is that? An ln. Yeah. Okay. Which is log base what? E. So I have to do the reverse. This should be as a single logarithm, or the word could be condense. 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 All right. Expand is the opposite of condense. Antonyms. Are we almost done with the notes? Some people look so bored. Whatever. All right. So what am I supposed to do with this 3, everyone? Make it an. The word starts with an E, and there's an X in it. There we go. Is it pre-Thanksgiving? Is that why we don't want to learn today? It's a small day, though. You got to admit. What am I supposed to do with this 2, everyone? Make it ooh, look at this. This okay, I guess I'll keep it, and then we'll do that. Minus ln squirrel y z to the 6th squared. Okay, and then this is what I mean about you should be able to eventually do this. This turns into one big fat ln, and then we can go ahead and do our exponent rule, which we just covered anyway. We didn't do product raised to a power, though. But we did power raised to a power, which means what do I do with the 4 and the 3? What do I do with those? Multiply. All these rules that you have to come into, that's why there's no screwing around. That's why, honestly, I think my ABers are in so much trouble. It's because last year, turn in your homework whenever you want. Everything's okay. Retakes, and that's what's not working. It's a disaster right now. I got a 49%, and the questions were log base 3 of 3, log base 3 of 9, log base 1/3 of 81. What is that answer, by the way? What is log base 1/3 of 81? There's a negative, right? How many people aren't even answering negative? Don't even know the negative exponent rule. This is the problem with all of that junk. It has created this situation right now. And I'm so terrified when those students go to college. Terrified. Scared. Worried. I can't sleep at night. I sleep okay. But probably a little too much. Does everyone know? Did you see what I did at the end?
Yeah.
Okay. Thanks for listening. All right. Oh, what? Holy jeez, what is wrong with these people? All right. Okay. All right, it's not too bad. It's not too bad. Okay, so what's log? By the way, what's the base on this logarithm? 10. And then what's 8 to the 1/3 power? 8/3. No. Okay, what 8 to the 1/3 power? 2. Okay, it's the cube root of 8. So I would hope you could do that without showing the work, kind of thing when we're evaluating. And again, this would be a multiple choice question. I don't want to see, I mean, you would do your work and then pick the right one at the end. This is a big one. Holy geez, Louise. And then I hope you could do this, right? This becomes squared up here, right? And then what's 6x become? 36x, right? X squared, sorry. I think you probably said that. I gotta take care of all these exponents first. Holy cow, they're just they're rough customers. All right, and then this is log. Okay, and then what's 1/2 power mean? Or maybe we might want to write this, and you could get lucky here. What's half of 4? What's half of 4? But what's the square root of 4? No, you could have got lucky if you accidentally thought it was half. And then what's log of 1,000 randomly at the end? 3. So when you can evaluate, go ahead. Now what's weird is, what do I do about this -3? I think we just kind of have to leave it as a chunk out there. All right. It doesn't really go down to the denominator because I've evaluated for it. Wild. Okay, so I'm going to go ahead and do that. This becomes log. Yeah, maybe I should wait. Yeah, that's wild. Maybe got me thinking again. This has to be allowed, so I got to leave this alone. This is log 2 plus log 36 x squared minus log, I'm just getting this evaluated, 2, not half, square root, and then y to the, what happens? What happens with 16.5? What do we end up getting? Is it 4 or 8? What's the exponent? 3, 2, 1, go. It's 8. I don't know if someone said 4. You're supposed to multiply those exponents. Basically, the square root of y to the 16 plus y to the 8. I'm going to stick with this because this is out of the logarithm game now. So this is going to be like a big Dogzilla 3 at the end. That's what I did there in a public school. All right. And then log. I don't want to get in trouble. I got people trying to cancel good old Mr. S every year. All right. And guess what? I'm still here. Anyway. Okay. So what do I do with the 2 and the 36? What do I do with the 2 and the 36? Put them on top, and then what do I do with those 2 and 36? Multiply. So this is 72 x squared over, and then this becomes 2y to the 8th. And then because I've evaluated, I'm really going to think about this. But that has to be allowed. It really does, because if we're told to evaluate, then I get that out of the logarithm. Wonder if I was supposed to do that and then leave the 1,000 on the bottom and then do some canceling. That's just really tricky and really messes with the student's mind. But anyway, what's 72 over 30 or 72 over 2, which I almost said the answer? 36. So again, these teachers have given you one that I wonder if they're leaving you open for a minus because that's not a single logarithm. But in my mind, that is a single logarithm with a little number on the outside, right? Okay, so anyway, I could maybe look at that a different way, but we can go for it. All right. Okay, so now, wait a minute. You just showed me this on here. Let's show that multiple choice. Remember this one? False. This is not at all what this is equal to. But I will show you what this is equal to right here. This is equal to, I guess I could, this is equal to like log base 9 of 27. That is true. All right. This is called the change of base formula, which used to have to everyone had to know. And the reason why is this. I'll tell you a little story. No one likes my stories, but that's okay. A little story. Let's wait a half hour for the calculator to open. we used to have the change of base formula, and I'm just gonna go ahead and play in the calculator right now and show you how this works. Every calculator had to have, I'm waiting, until the bums that made calculators gave you this button. This button never used to exist. It didn't exist on any scientific calculator until the graphing calculator later made this button, and then scientific calculators made the button. So notice what I had on that previous page. Wasn't it log base 9 of 27, right?
Yeah.
Does anyone know what log base 9 of 27 should be, by the way? This is something we should be able to figure out. What am I going to get as an answer? Think about what you have to do to 9 to get it. What's a common base between 9 and 27? 3. What do I have to do to 9 to get it to 3? Square root it, and then what do I have to do to 3 to get it to 27? Cube root it. So what's the answer? 3 halves, right? Boom, that's 3 halves. Got it? Now, I don't have that button. Let's pretend. So you got to be careful with Oh, that's my COVID wall right there. All right. Okay, thank you. Somebody cares. All right, let's do another button that never used to exist. The fraction button. You guys are so spoiled. Anyway, here is, what did I say? Log base, I can't even do log base 3. I gotta use the illegal button. Didn't I say log base 3 of 27 over log base 3 of 9 would be the same answer? We actually know what log base 3 of 27 is. What's log base 3 of 27? 3. What's log base 3 of 9? 2. 3 halves. Okay, but what's the only other log button that we have? We have the log base what? Log base what? 10. Let's not be sloppy. Over log base 10 of 3. Oh, it was supposed to be 9. Whoopsie daisy. I'm glad this is on the video. Second entry, let's change that to a 9. My bad, dogs. Anyone? Well, 3 halves. Ooh, nice. Watch this. Now, Len, wrong. Okay, let's do it the old school. This is what the kids back in 2008. Oh, 2008 had to do. They had to do this. Parentheses, ln, 27. That's a parenthesis, so I have to close and then close. That's the numerator. Oh, so many buttons. I don't know how they survive. And then the denominator, I'm not sure you need that parenthesis. I know I need the first one still. Ln of 3. What do you think you're going to get, everyone? Same answer. What did I just did it again. All right, I'm in maroon. Okay, sorry, that was supposed to be 9. So caught up in the math here. Boom. And that, my friends, is the change of base formula. All right, it doesn't matter what base of the logarithm that you use, but to evaluate this, this is on the bottom, this is on the top. And everyone had to know it because nobody had those cheating buttons. Everybody had it. All right, and then the graph logarithms of different bases, they had to type it in this in the Y1 screen. All right, and that was not really actually that long ago. It's probably about the mid 2013, 14 that some of these calculators started coming out with that actual button. So when they say rewrite this in terms of a base 3 logarithm, this would equal, rewrite in terms of natural log. Okay, so I got not much room here. This would be log base 3 of numerator over log base 3 of denominator. And everyone had to do, or base, sorry. The base is in the denominator part. And everyone had to know how to use that button. How to write it in terms of natural logs, ln of 8 over ln of 7. And then common logarithms, log 8 over log 7. So before that button existed, everyone had to know the change of base button. All right? And then know how that actually works. Okay, and is that how we end? Okay, then some random solve. Okay, so using only natural logarithms. Now, don't be making up a rule about this. This is the, what do we call that? The argument, and then this is the base. So to write this in natural logs, it's ln of the A argument over ln of B, the base. This is not the same as the division rule. Not at all. Okay, not at all. Write this in terms of natural logs. That's interesting. By the way, what's the base on this logarithm right here? What's the base on this? What's the base on this? 10. So this is ln of answer argument over ln of base, the ghost. By the way, what's ln of E? What's ln of E? What's ln of E? What's ln of E? 1. So you're required to do those evaluations if they come up. Over here, there's nothing to do. In fact, it's a big fat mess. And don't be making up a rule on this. There is no rule for that. It had to be ln of x minus ln of y. Doesn't have an ln on that y. All right, so understand that difference. All right, and then just follow the rules. Oh, there we go. There we go. We got a little extra on this next one. Rewrite this using common logarithms. If this will help you, cross it off and make it log base e. So then to write it as common, that's the log base 10 button, not the ln button. That's why I had to write this ln as log base e. So this is just messing with your mind. Do you know your rules? Do you know what you're looking at? Do you know your bases? Do you know the difference? Do you know, do you know, do you know? And that's it. There's nothing else to do. You can't evaluate log E. Log is base 10, E is E. There's no correlation between those two. And then common logs, yep, they went ahead and did it. Log of 0.0001 over log 2. What's log of the, what's that numerator? What does that become? 3, 2, 1, go. -3, -4, which one is it? Okay, so read this. This is 1. What is this position? This will help you. What position is that? 10 thousandths. Okay, 1/10,000ths. So 1 over 10,000. How many zeros is in 10,000? 4. So it's -4. Okay, over log base 10 of 2, which I'm not going to write. Okay, everyone good? Did the first bell even ring? Oh, my bad, dogs. I went farther than I wanted to. Solve the exponential equation. Review. This is what's going to happen after break, not this. And then that's when we have to use logarithms. But what can we do? What's 9? A number. 3 squared. And then what we were able to do before, like a while ago, was, well, we know this. So that means we have equal bases, and then we have the exponent rule where we multiply these two exponents and then drop the bases. Remember that? If 3 to this power equals 3 to that power, that's only if this power equals that power. Okay, that's not going to happen after break. When you can't get equal bases, you need the glory and power of logarithms to solve. And that's what you're going to run to when we get back. But in order to solve logarithms, you really got to be a master of the properties that we just went through. Okay? The change of base property is kind of archaic now, though. That button ruined it in a way. I don't really see much application to it anymore. But you're still going to have to know it. Fumble. Should have hit the pause or end. Bye, everybody. Happy Thanksgiving. Nope, that didn't work.